So we will start with the basics of sound today. So what is a sound? If you study it carefully, you will see that sound is nothing but pressure waves. So we generally draw it as a wave format, but what are these lines we will see later. And basically it travels based on the pressure difference. So if you create a pressure difference, you will get a sound. One most important example is a compressor where we release the air from the compressor, you will get this particular frequency sound. And one more example could be any machine that has a rotation. When it rotates, the rotary part makes a sound. Sound can be treated as a longitudinal waves. So its amplitude of oscillation and it has a direction of propagation. So sound is a directional phenomena. Like if you have certain amplitude in certain direction, in the opposite direction, the amplitude will reduce. For humans, sound waves lies in the range of 20 hertz. तो आप 20 hertz से लेके 20 kilohertz तक sound सुन सकते हो. So for females, the frequency is higher compared to the males. Like whenever you see the announcement on a railway platform, they are made typically in female voices because female voices has a higher frequency. So they are easily audible even in the crowd noise. And that's why railway announcements are made in the female voice. Now, another sound basic is what we study is it's a sensation or perceived as a vibration. Basically, it's the air pressure difference that is detected by our ears. Now, our ears can convert this vibration into the electrical impulses. These impulses are transmitted to our brain via our nervous system. So our brain then distinguishes it as the three main characteristics. We will learn about these terms later. One is pitch, the second one is timbre, and third one is loudness. So let's understand what is the propagation of a sound. यहाँ पे हम देख पा रहे हैं कि there are some these black dots are nothing but air particles, and basically what we are doing is when we see the compression and decompression patterns in this, our sound has a eardrum inside which vibrates and then it can listen to the sound. So if you try to plot a sound wave against time, you will actually see a pressure sinusoid wave generated in certain direction. And this atmospheric pressure will have two things. One where we see a compression, something like this, and one where we see a rarefication. So our ear can change, pick up this change in pressures, and this is what is transmitted to the brain via a nervous system. Now, हमने ये टर्म बहुत बार फिजिक्स में सुना है, 344 मीटर पर सेकेंड velocity of the sound. It depends on temperature. So typically the velocity of sound is depend on root of t, where t has to be in degree Kelvin. So in exam, you might receive a sum that at 20 degree, the speed is 344 meter per second. What will be the velocity of the sound at 40 degrees Celsius or 80 degrees Celsius? Then first thing you have to convert it to a degree Kelvin by adding 273 to it. And similarly, you can calculate original T1, which is proportional to V1. The value is this, and T1 value is 20 plus 273. Then if I take a ratio of new velocity V2, then it can be given by new temperature T2, provided you take a root of the both. So this is the formula we have to use to calculate a new velocity V2. अब इसमें unknown क्या है? V2. V1 है आपका 344 मीटर पर सेकेंड. T1 जो है वो 20 plus 273, which is I guess 293 हो गया. और 40 डिग्री जो है दैट इज 40 प्लस 273 शायद 313 डिग्री. सो इसका रेशियो, इसका रूट लेंगे एंड देन यू क्रॉस मल्टीप्लाई टू गेट द वैल्यू ऑफ V2. So this is how you should able to solve the velocity in terms of the temperature. Next is हम लोग हमेशा dB सुनते हैं when we go for purchasing of any sound system, even your headphones. It should always be mentioned something in terms of dB. So let us understand what is this term dB. So dB is nothing but a logarithmic ratio. So power p to uh, zeroth power, that is p naught, which is a constant. Typically, it is 2 10 to the power minus 5 pascals. And then LP, that is sound in terms of pressure, can be given by this formula 20 P by P naught log of. Now, this P naught is a fixed value calibrated for the lowest sound that we can receive. Now sound can be measured in terms of power also. This is more common formula. ये आपने बहुत बार आपके electronics EDC या फिर sound amplifier इन subjects में भी सुना होगा. 10 log of W by W0, where W is the actual power in watts and W0 is the power at 1 picowatt. So 10 to the power minus 12 watt. Similarly, these all are for the sound system. When you do it for electronics, you will have your input power and output power. Similarly, for sound system, when measured in terms of intensity, they are given by formula L1 equal to 10 log I by I naught, where I is an intensity and I naught is 10 to the power minus 12 watt per meter. अब ये number आप ध्यान में रखो. It is 10 to the power minus 12. So that is 1 pico. Now there are terms something like watt per meter square. इससे आपको ये समझ में आता है कि this is power distributed in an area. So let us understand हम कितना low noise सुन पाते हैं. Okay. So अपने ईयर की कैपेसिटी है कि आप 1 picowatt per meter square तक का साउंड सुन पाते हो. This is the lowest, what we called is as threshold of hearing, and it is just about audible sound. So basically, if you receive a pressure 2 to the power 10 to the power minus 5 Newton per meter square, then you can listen to this sound. And there is something called a threshold to the pain. इसके बाद आपके कान में दर्द होना शुरू हो जाता है, and that particular sound is 10 watt per meter square. So it has a pressure of 63 Newton per meter square. So this is a painful sound, और इससे आपको hearing loss भी हो सकता है. बहुत बार आप सुनते हो कि eardrum will get damaged. Even if you try to increase your mobile sound after headphone, if it is headphone, after 9 it will show an error that it might damage your eardrum. And if you don't wear a headphone, you can put your sound to maximum. The reason being, when you wear a headphone, the speaker or sound source come very close to the eardrum, and if you play a very loud sound at this particular point, then you might damage your ear. So at young age, we don't realize we wear a headphone and play a very loud sound, but that is not good when because the drum is vibrating. So you can imagine it as a rubber. Rubber can go forward and backward, but if you do it, it will have its own lifetime. So typically after certain lifetime, this rubber starts getting hardened, and then it doesn't move, and then there is a chance that you develop a hearing loss at the age of 40 44. So this is very bad. If you are listening to very loud sound in your headphones, please stop doing it. At least I don't want my students of sound, that is audio and video engineering, to do such mistakes. So let us understand how these decibels or sound are actually related. So hearing threshold is at 0 dB. So 1 picowatt is what we said. Then there comes the sound of leaves. So leaves create a sound in 20 dBs. Somewhere between 20 to 40, around 24, there are whispers. Then soft music like violin or any string instrument played at 3 meters away from you has a म्यूजिक ऑफ 40 dB. अब आप ध्यान में रखो कि आप जब ये म्यूजिक साउंड डिजाइन कर रहे हो, तो आपका जो बैकग्राउंड म्यूजिक है दैट शुड गो बिलो 40 dB फ्रॉम द ऑडियो वॉइस सिग्नल. टिपिकली द वॉइस इज अराउंड 60 dB. सो हम जो बात कर रहे हैं अभी भी, इट शुड बी अराउंड 60 dB. द कार नॉइज, आप इंजन के अगर नजदीक जाके सुनोगे तो इट मेक्स 80 dB साउंड. योर मिक्सर विल क्रिएट अराउंड 90-94 dB. Then in the large concert, if you stand next to the speakers, the big rectangular speakers जो black color के रहते हैं, वहां पे 120 dB तक साउंड आता है, और उसके बाद जेट एयरप्लेन इंजिन जो है that makes a sound roughly around 130 dB, and then after 140 everything is harmful. So you will see, if you try to purchase a speaker system, you will never get a speaker system more than 100 watt if it is ISI branded or any other certified branded equipment. You will never get a speaker system above 100 watts. It should say 100 watt dB or something like that. uh, Generally they write 800 watt or like that, but that is PMPO. We will go into these terms later, but this is not the actual power. So basically anything near 50 to 100 watt is good enough for us to work with. Now, here is the sound signal when you plot it on a software. This is how it actually looks like, and it will have one time axis. So it is obviously a fluctuation. And if you see, this is a 1D signal. So sound is treated as one dimensional signal. So if you are learning signal processing in the same semester, this is where you first introduce a 1D signal, which is it is varying a value with respect to time. Now, how this particular sound system works, let's try to understand with the diagram. So when persons speak, it generates a vibrations that is captured by a microphone. There are multiple types of microphone, we'll study them. Then it goes to a ADC, or through a signal conditioning, it goes to the ADC. Then it goes to a digital system. Then further it goes to a DAC, and finally analog signals are being played at the speaker. So these are the steps through which the sound generally goes through, and digital system might do any post processing onto the sound, such as removing the background noise and all, which is our first experiment also. So we will learn how to remove a background noise from the sound using this digital system. Now, if you try to say a waveform saying Sunday, so आपको ये waveform दिखा दिया, तो you should realize that this particular part is when we say Sunday. And if you zoom into AY, into this Sunday, you will see this kind of waveform in your Sunday pronunciation. So अगर आप Sunday बोलते हो, तो उसका this is what we call sound pictures. ये एक पिक्चर और पिक्टोरियल रिप्रेजेंटेशन है साउंड का, एंड दिस इज हाउ इट लुक्स लाइक. आप अभी समझोगे कि हाउ अ डायनेमिक माइक्रोफोन वर्क्स. ओके, नाउ जनरली व्हेन वी से डायनेमिक माइक्रोफोन, ये स्पीकर भी हो सकता है या माइक भी हो सकता है. इट वर्क्स इन बोथ वेज. So a single instrument can act as a speaker and as a microphone. So basically sound waves, which are the pressure changes in air, goes and hits to this particular coil. Basically this coil is attached to the diaphragm. ये पतली सी मेम्ब्रेन रहती है जो जिसपे साउंड प्रेशर हिट करता है, तो ये कॉइल को मूव करती है. And there is a magnet inside this diaphragm which goes front and back, and then basically because of that the two wires carrying the audio signal. ये आपको शायद याद होगा फर्स्ट ईयर में कि अगर मैग्नेटिक फील्ड में कोई कंडक्टर अगर मूव करता है, तो इट मेक्स अ करंट फ्लो थ्रू दैट कंडक्टर. शायद उसको फैराडेज लॉ या कुछ तो बोलते हैं. लेफ्ट हैंड रूल एंड राइट हैंड रूल, ऐसे दो रूल आपने सीखे होंगे. एक मोटर के लिए अप्लाई होता है और एक दूसरा ट्रांसफार्मर के लिए. सेम प्रिंसिपल अप्लाइज हियर. यहाँ पे एक मैग्नेट है, परमानेंट मैग्नेट रहता है जिसकी मैग्नेटिक फील्ड बनी रहती है. And when this diaphragm moves, what will happen is this field gets cut, and because of which the current get induced into the microphone. Now when you see those induced current, they look like a sinusoids. अब आप ये बोलोगे कि ये exact sinusoid नहीं है, but it's a addition of multiple sinusoids. So आपका sound signal जो है वो हमेशा sine waves से बना रहता है, पर अलग अलग frequency के sine waves अगर आप ऐड करोगे तो आपको ये अजीब सा सिग्नल दिखाई देगा. And then we do a sampling and quantization. So शायद आपने सिग्नल सिस्टम, बहुत सारे सब्जेक्ट्स में कम्युनिकेशन, आपने सैंपल एंड होल्ड सर्किट पढ़ा होगा, which basically points these samples and then try to quantize it to the nearest level. And this is the process of sampling and quantization. तो जितना आप ज्यादा लेवल यहाँ पे जनरेट करोगे उतना आपका बेटर साउंड प्रोड्यूस होगा, बट एट द कॉस्ट ऑफ मेमोरी. So here are the 4 different waves. If I tell you all these waves have the same magnitude, you will say, yeah, correct, because the y-axis has a similar magnitude. But the only change between these is the time period. So each of them has a different time period, and that is what we call change of frequency. So since it's a 1D signal, it will have its 2 properties. One is voltage, which we call amplitude, I will say Vamp, and the second one is time, which is directly or inversely proportional to frequency. So there are 2 characteristics associated with the sound signal. One is voltage and second one is time. So sound pressure, what we call it as a volume. The frequency range is sometimes is known as dynamic range. तो आप DR वगैरह वर्ड अगर साउंड इंजीनियर के मुंह से सुनोगे तो that is nothing but frequency range or dynamic range. Then there is concept of audio filtering. So not all audios are audible to the human ear. So you can remove out some of the filters. आपने ये डिजिटल कैरियोके करके कुछ चीज सुनी होगी, तो जिसमें हम वॉइस और वोकल फ्रीक्वेंसी को बैंड रिजेक्ट फिल्टर से पास कर देते हैं, जिसकी वजह से आवाज निकल जाती है और पीछे के बैकग्राउंड म्यूजिक फिर भी सुनाई दे रहा होता है. सो टिपिकली फॉर टेलीफोन सिस्टम्स we use a sound frequency of 3.4 hertz, that is up to 3.4 hertz. कोई बात करता है तो सुनाई देगा. And for music systems it is around 20 k. Now there is something called as pre-emphasis and de-emphasis circuit. We will see that later in the syllabus, what is pre-emphasis and de-emphasis. Then there is some concept of compounding, that is compressing and expanding. And then finally a very important concept of noise reduction we are going to learn in this course. So let us try and understand what is there inside a sound signal. So if you try to plot any signal, signal will have its 2 properties. One will be the amplitude and second will be the time. So if you try to plot a signal against time, this is how it would look like. It will be very random waveform. It does not make any sense to a human watching this particular waveform. Now if you see at least 1 second of sound signal, this is how it will look like. It's totally what we call say noisy, and it doesn't make any sense if you see it in a time domain. So that's why we have to go to the frequency domain. Now analog and digital signal concepts you might be knowing. Analog signal can take any value between 0 to whatever maximum magnitude with respect to time, whereas digital signal can only have 0 volt and 5 volt typically, or logic 0 and logic 1. Some cases it is 1.2 volt also, some cases it is -5 to +5, but only 2 levels. So basically digital signal will have a 0 or 1. Now when we call a filter, हम assume करते हैं कि this is a low pass filter, this is a high pass filter. तो certain cutoff frequency के पहले के सारे frequency पास हो जाएंगे, उसके बाद के पास नहीं होंगे. और हाई पास फिल्टर में सर्टन कट ऑफ फ्रीक्वेंसी तक सारे फ्रीक्वेंसी को 0 गेन मिलेगा और उसके बाद के सारे फ्रीक्वेंसी पास हो जाएंगे. पर प्रैक्टिकली ऐसे फिल्टर बन ही नहीं सकते. तो प्रैक्टिकली जो आपको फिल्टर मिलते हैं वो ऐसे होते हैं, स्लो रोल ऑफ वाले, फास्ट रोल ऑफ वाले, रिपल इन पास बैंड, मतलब इस तरह से. आप अभी डीएसपी सब्जेक्ट शायद पढ़ रहे होंगे, उसमें ये सारे कंसेप्ट आएंगे. देन फ्लैट बैंड पास वाले फिल्टर भी रहेंगे. Then poor stop band attenuation, which we call ripples. यहाँ पे आपके मेन गेन के बच्चे पैदा हो जाते हैं और उसका मैग्नीट्यूड कम होते जाता है. Then we say a good stop band attenuation, and then there are very slight ripples at the base. So these are the different types of filters. On this side you will see all poor filters. So this is poor, this is poor, and this is poor. And on this side they all are very good quality filters. Now let us understand what is a quantization. If I give you 3 bits and ask you to draw this red waveform in terms of these 3 bits, let us try to see what will happen at this particular location. So if you see this quantization level is 1111, तो इसके ऊपर का ये सारा सिग्नल जो है वो ट्रांसलेट हो जाएगा as 1111. So if you start plotting this waveform, first you will get 100 for this particular point, then you will get 101 for this particular point, then you will get 110 for this particular point, then you will get 111 for the top position. After that you will get again 111, then you will get 110. So in exam they might give you certain random wave and ask you to find its binary signal. So I guess by drawing this quantization curve, it will be very easy for us to determine corresponding binary signal. And you can keep doing this. Then next value will be again 110. उसके बाद आपको हर पॉइंट पे देखना है, हर पॉइंट पे देखना है, तो इस पर्टिकुलर पॉइंट पे सीधा यहाँ पे आ गई ये वैल्यू. So next point will be directly 110. Sorry, 100. So you have to shift in time every time you read a signal. तो यहाँ पे क्या हो रहा है, इस पर्टिकुलर लोकेशन पे एकदम 2 से मैग्नीट्यूड कम आया है, तो उसके नेक्स्ट टाइम पॉइंट पे सीधा ये पॉइंट रीड होगा, मतलब ये पॉइंट रीड होगा और फिर ये पॉइंट रीड होगा. डोंट ट्राई टू इंसर्ट दिस पॉइंट. ओके, सो दिस इज हाउ यू रीड योर डिजिटल सिग्नल. Next is how to detect a speech or to detect a noise. That is our one of the experiments where we will find out the noise and where the signal is. So this is what we call the speech detector, or what we call it as a background noise removal, or whenever somebody is speaking, you will get this kind of waves, sudden waveforms, and then this is a false detection. Okay, then there is a wave over here, wave over here. This is again, there is a pause in between which was not detected correctly, wave here, wave here, again a false detection, there was a wave but which was not detected, detected. So this is how sound detection is one of the biggest what we call say signal processing challenge, and you can work on it as a software project. Now let us see what is a dry signal. तो हम ऑडियो इंजीनियर्स के मुंह से सुनते हैं कि डायरेक्ट ऑडियो आ रहा है या फिर ड्राई ऑडियो आ रहा है. सो बेसिकली ड्राई ऑडियो इज नथिंग बट माइक्रोफोन इज डायरेक्टली कनेक्टेड टू द स्पीकर. इस तरह की सिस्टम आपने देखी होगी, जब पुराने जमाने में अनाउंसमेंट माइक्रोफोन होते थे, हम उसको भोपू बोलते थे, जहाँ पे माइक्रोफोन के साथ ही आगे स्पीकर और एक हॉर्न जैसा लगा रहता था, और यहाँ पे यूजर उसको पकड़ के उसी में बोल देता था. तो यूजर का वॉइस जो है वो सीधा यहाँ से माइक्रोफोन में जाता था, बीच में एक ट्रांजिस्टर एम्पलीफायर रहता था विद गेन ऑफ 10, एंड देन देयर इज अ स्पीकर. सो दिस इज व्हाट वी कॉल्ड अ डायरेक्ट सिग्नल सिस्टम और ड्राई सिग्नल सिस्टम. Then comes a processor in between. So what we call it as a in series equalizer. Now here the audio signals are processed in line. So whenever you say in line or line input, that means it has gone through a one stage of processor. So आप जब भी माइक्रोफोन या इनपुट देखते हो तो पीछे आपको डायरेक्ट और लाइन इन ऐसे दो वर्ड दिखाई देंगे. तो डायरेक्ट वाले में सीधा आपको माइक्रोफोन कनेक्ट करना होता है, whereas लाइन इन जहाँ लिखा होता है वहां पे आउटपुट ऑफ द फर्स्ट स्टेज एम्पलीफायर लगाना होता है. तो आउटपुट इज मॉडिफाइड फॉर्म ऑफ द इनपुट, दैट इज नॉट अ डायरेक्ट सिग्नल और ड्राई सिग्नल. Then you can have a dynamic balance in series with the compressor. So what is a dynamic balance and what is a compressor we are going to learn in later part of this course. But basically try to understand this is not a filter. This is what we call the compressor. Compressor का main purpose रहता है कि to generate a compressed waveform. That means higher frequencies are having less amplitude and lower frequencies are having more amplitude. Something like a high low pass filter, but not exactly low pass filter. We will see why later on. Next is you can have line in, that is the modified waveform, and then compressor at the in series, and here you will see a dynamic balance connected in series with the equalizer, and then there is a compressor. So you can have both in sync or in series, and you also can be using an amplifier where you can create a distorted sound or saturated sound or modulated sound of the inputs. आपने इस तरह की चीज आपके गिटार के एम्पलीफायर बेस के साथ देखी होगी, वेयर द गिटार सिग्नल्स आर मॉडिफाइड, और उसमें आप अलग अलग इफेक्ट डालते हो, स्पेशली विद द इलेक्ट्रिक गिटार्स this kind of distortion, saturation, modulations are used. Again, everything goes into the series. Now there is something called as series parallel combination, where the direct sound is also fed to the speaker and the process sound also fed to the speaker via some process. So इसको हम reverb जैसे effects में use करते हैं. Reverb या mixed playback, something like you sing from one microphone and then there is a karaoke backtrack played from another. So this is what we call a series parallel. So whenever you see a complete parallel system, all the units are connected in parallel, very similar to the electronic circuit. Whereas in the combination of series parallel, you might have a series compounder and then there is a parallel expander, then another series expander and something like that. So this is what we call a series parallel combination. Next is you can also have a very much process signal where the delays and other inputs are added to generate the parallel systems. Then you have series parallel combination. Like I said, there is a low pass filter, there is a compounder, and then there is a delay block. So this is how you can add them. Then you also can have output amplifier current sound control. So the general methods of processing, हम ये सब बहुत कम बार सुनते हैं. They are equalize, compressor, filter, gating, chorus. Now don't worry about these alien terms right now because we are going to learn all of them in detail. Then there is something called a distortion, saturation. तो ये सारी जो चीजें ये हमेशा सीरीज में आती है. And in parallel you will always have reverb, delay, echo. These are the things that goes as a parallel processor. So remember, whenever we are carrying out the operation, you must understand what are the series operations and what are the parallel operations. So what is the basically meaning of a audio signal term? Let's try and understand this. So audio signal is a representation of sound, typically a electric voltage. They have a frequency range from 20 hertz to 20 kilohertz and they limits the human hearing. Now audio signals can be synthesized directly or may be originated from the transducers such as microphone and musical instrumental pickup. There are something called as phonograph also, then cartridge or head tapes also. So these are the things that can generate a sound signal. So loudspeakers and headphones are the one that convert the electrical signal back to the sound. So you generally have a sound system consisted of, जैसे आप साउंड सुनोगे आपको पता है कि इसमें स्पीकर लगने वाला है या फिर माइक्रोफोन लगने वाला है. Now digital representation of this signal is also exist in variety of format. Some of them very popular is, आपने सुना होगा MP3 करके एक होता है, उसके पहले आता था डॉट वेव. Then there are new formats like dot OGG, and nowadays everyone is talking about MP4A. A stands for audio. So these are the some common formats. उसके अलावा भी बहुत सारे format होते हैं audio के. We will learn them one by one later in this course. Now, audio channel or audio track is a signal. How many channels a audio particular has? आपने बहुत बार सुना होगा stereo. Stereo is most common. But basically other than that there are some other multi-track sound system जैसे आपने सुना होगा 5.1, 7.1, 21.1, etc. These are the different sound format. Now, signal flow path for an audio signal will take it from the source, that is microphone, up to the speaker. That is what we call the signal flow path. And it is most frequently in the recording settings where the signal flow often is very long and convoluted with help of the electrical signal. They are passed through many analog consoles, external audio equipments, and even different rooms. Now, audio signal may be characterized such as bandwidth, which we haven't seen yet, power level, which have just introduced in this lecture, then voltage level, which we haven't seen yet. Then there is a relation between voltage and power with respect to the impedance of the path. तो आप जब भी माइक्रोफोन या स्पीकर खरीदने जाओगे तो लोग बहुत कॉमनली बोल देंगे कि कितने ओम का चाहिए, एंड द टिपिकल रेंजेस आर 4 ओम, 8 ओम एक्सेट्रा. तो बेसिकली ये जो ओहम है ये उसके अंदर के कॉइल का रेजिस्टेंस रहता है. तो जितना कम रेजिस्टेंस वाला स्पीकर लोगे उतना ज्यादा करंट उसमें से बहेगा. जितना करंट ज्यादा बहेगा उतना वो लोडिंग ज्यादा करेगा एम्पलीफायर को. तो अगर एम्पलीफायर बना हुआ है 8 ओम के स्पीकर के लिए एंड इफ यू कनेक्ट 4 ओम स्पीकर, करंट सिंक हो जाएगा और एम्पलीफायर लोड हो जाएगा, एम्पलीफायर हीट हो जाएगा और साउंड अच्छे से नहीं आएगा. So there is some concept of impedance matching or maximum power transfer which will only happen if you connect 8 ohm speaker to a 8 ohm amplifier. So remember, you have to choose your speakers carefully when you go to the market. Audio signals have somewhat standardized level depending upon the applications. For example, mixing consoles are generally line level signals. Microphone outputs are called lower level inputs or mic level. So यहाँ पे दो level रहती है, एक line level और mic level, which I already told you. At the back of any audio system, you will see mic in, and then there will be another jack says line in. So these are the two things you will see at the back of the audio system. तो आपको आप शायद पता चल गया कि अगर आपके पास माइक्रोफोन है तो उसको माइक इन में लगाना है, ना कि लाइन इन में. सॉकेट सब सेम ही दिखते हैं. तो कोई इनकम्प्लीट या जिसने ऑडियो वीडियो इंजीनियरिंग का कोर्स नहीं किया है हुआ है वो बंदा ऐसे मिक्सिंग कर सकता है लाइन टू माइक, पर आपको ये नहीं करना है बिकॉज वी नो व्हाट इज अ माइक इनपुट एंड व्हाट इज अ लाइन इनपुट. Now there are older analog equipments which do not have any digital form. They generally have these kind of systems like audio in or microphone in. Nowadays you have digital audio workstation, हम उसको DAW software बोलते हैं. Basically ये computer software है which can plug in any input hardware via its sound card. So आपके PC में अगर आपने सुना होगा there is some concept of sound card. So that is what we do through the hardware using this.